Hi friends, this is Rashekar, a GET faculty for electrical machines. Today in this video, we are going to discuss about the connection of delta star. Delta star connection diagrams. So let's see here. First of all, the phase turns ratio. Phase turns ratio, I said you same x is to 1 for all connections. This is constant. And next one, line turns ratio. Line turns ratio is equals to, tell me, what is the line voltage of delta? The line voltage of delta is equals to phase voltage. And what is line voltage of star? The line voltage of star is equals to root 3 times of phase voltage by turns ratio x. This phase voltage gets cancelled out. So the line turns ratio is x is to root 3. Remember this. The line turns ratio is x is to root 3 for delta star connection. For delta star connection, line turns ratio x is to root 3. We will talk about this later. Now take the connection diagram. Delta star. Take delta and star connection diagram. We know how we can draw the delta and star connections. How we can draw the delta and star connection. We know that, for example, these are the three phases. These are the three phases of primary and secondary. We know these are represents with capital letters and these are represents with small letters. This is A2 and this is B2 and this is C2 and A1, B1, C1, A1, B1, C1. Of course, dot notations are at this point like this. This is the three phases of primary and secondary. And here the primary is the delta. So we have to draw the delta here. Now the A1 is connected to B2 and B1 is connected to C2 and C1 is connected to A2. C1 is connected to A2. And here this is the star. So all the three A1, B1, C1s are connected to a neutral point N. This is my neutral point. This is a delta star connection diagram. Now draw the arbitrary delta and star. Draw the arbitrary delta and star. Let's see here between A2 and B2. From A2 to B2, capital A is connected. From B2 to C2, capital B is connected. From C2 to A2, capital C is connected. So take the arbitrary delta here. This is a capital A and this is a capital B and this is a capital C. The capital A is connected in between A2 to B2. Capital B is connected in between B2 to C2. Capital C is connected in between C2 to A2. And take the dimensions here like this. This star representation in the delta. This is for delta, arbitrary delta. Now draw the arbitrary star. And you know that these are in additive manner. In additive connection, the vectors are in parallel. In additive connection, vectors are in parallel. In parallel, nothing but if capital A is like this and small a also should be like this. Capital B is like this. From the neutral, small b also should be like this. Capital C is like this. From the neutral, small c also should be like this. This is the neutral point. This is the neutral point. And here from the neutral A2, from the neutral B2, from the neutral C2. This is the arbitrary star and arbitrary delta. Now these two superimpose on a clock. What is that? Superimpose these two on a clock. Right? Let's take the clock. Let's take the clock. For example, this is my clock. Here 12 o'clock and here 6 o'clock. Of course, here 5 o'clock, here 7 o'clock, and here 1 o'clock, and here 11 o'clock. 11, 12, 1, 5, 6, 7. This is our clock. Now superimpose this. This is the minutes hand. This is the minutes hand. This is the reference. Actually, my minutes hand is at 12 o'clock. But once see, where is our hours hand? This is our hours hand, hours needle. This is in this direction. The hours hand is in this direction. This is small a. Now tell me, what is the phase difference? What is the phase displacement? See here, the primary is the delta. Primary represents with capital letters. Secondary is the star. Secondary represents with small letter. Primary is the delta. Secondary is the star. And the time is 5 o'clock. And the time is 5 o'clock. See, the time is 5 o'clock. If it is 6 o'clock, it is 180 degrees. But it is only 5 o'clock, hence the angle is 150 degrees. The angle is 150 degrees. Nothing but in delta star connection, the one configuration angle is 180 degrees, which is nothing but 180 minus 30 degrees. 180 minus 30 degrees. Yes or no? If it is here 180, but here this much is less. So 180 minus 30 degrees is equals to 150 degrees for this configuration. This is a delta star first configuration. We got 150 degrees of phase displacement from primary to the secondary. From primary to the secondary. For example, let's try for second configuration in this. Let's try for second configuration in this. Let's see here. I am doing the next configuration. For example, this is the primary winding. This is the primary winding. And for example, this is the secondary winding. This is the secondary winding. Primary winding and secondary windings are there. And we know this is a capital A, capital B, capital C, small a, small b, small c, small a, small b, small c, and dots are like this. Of course, this is A1 and A2, B1 and B2, C1 and C2, A1 and A2, B1 and B2, C1 and C2, right? Now let's draw. This is in delta. Don't change this delta. Delta is similar to this one. This delta should be similar to this one. So see how it is. A1 is connected to B2, B1 is connected to C2, C1 is connected to A2, C1 is connected to A2. I didn't change the delta of primary, but now we have to change the star. Star here, I am connecting these three phases to the neutral. Neutral. This is undotted is open. This is dotted and this is undotted. Undotted is open. This is dotted is open here. Nothing but this is the additive manner or subtractive manner. This is the subtractive manner. This is a subtractive manner. Nothing but 180 degrees displacement between primary and secondary vectors during the configuration notation. Let's see, draw the arbitrary delta. Arbitrary delta. This is capital A. Of course, this is capital B. And this is capital C. The capital A is in between A2 and B2. Capital B is in between B2 and C2. Capital C is in between C2 and A2. And represent here and represent here. This is our delta. Are you okay? Listening or not? Now we have to draw the arbitrary star here, but the star should be, the vector should be exactly 180 degrees to these vectors. Let's draw. Here my A is like this. We should follow the phase sequence. We should follow the phase sequence. See here, A, B, C. And here, A, B, C. We should follow the phase sequence. We should follow the phase sequence. A, B, C. Here also, A, B, C. Here also, A, B, C. Here also, we should follow the phase sequence. Right? Let's see here. Let's see here. A is like this. Nothing but from the neutral, exactly opposite direction. From the neutral, exactly opposite direction A. A. And B is like this. From the neutral, exactly opposite direction B. And C is like this. And here exactly in opposite direction. This is my C. This is my C. See, A, B, C. A, B, C. Again, we have to follow the phase sequence. Must and should. Now see here. Now see here. This is neutral, and A for A1, B for B1, C for C1. Now arbitrary delta and star is completed. Now let's superimpose these two. How we can superimpose? How we can superimpose? Take a clock. We know here the 12 o'clock, here 1 o'clock, and here 11 o'clock, and here 6 o'clock, here 5 o'clock, here 7 o'clock, here 7 o'clock. So this is my clock. And see, this is the reference vector. Always this is the reference vector. Here my reference vector again at 12 o'clock. But see, my secondary vector, nothing but hours hand. Hours hand is in this direction. Nothing but my hours hand is in this direction. This is my small a. This small a is advances a primary by some angle. What is this angle? This angle is 30 degrees. This angle is 30 degrees advanced. Here my secondary vector advanced primary vector by 30 degrees. Nothing but this is 30 degrees leading. This is 30 degrees leading. Here the phase difference is 30 degrees. Is generally nothing but 0 plus 30 degrees is equals to plus 30 degrees. Plus 30 degrees leading. Here 180 minus 30 degrees, but here 0 plus 30 degrees. 0 plus 30 degrees. So here how we can represent? Primary is the delta and secondary is the star. Secondary is the star and time is 11 o'clock and the time is 11 o'clock. It represents that plus 30 degrees or 30 degrees leading. This is very important. They may ask you question on this. This is already asked in previous GATE and IES on delta star and star delta. These are very important for competitive exams. They will ask you question, is 30 degrees leading or 30 degrees lagging? Like that they will ask you question. This is very important for competitive exam. So these are the two configurations. What I done, just I simply take my primary, but I changed the secondary configuration, secondary winding connections. For that, I got two angles. One is 180 minus 30 degrees. Another one is 0 plus 30 degrees. Now, we have to go for another two configurations by changing the primary winding. By changing the primary winding. If primary winding changes, how the configuration is there? What are the phase differences between primary and secondary? Let's see. Okay, this is clear up to now. Clear the two configurations of delta star and remaining two configurations are there. Let's see for them. So next, the remaining two configurations in delta star. See here, this is the primary winding and this is the secondary winding, three phases. Secondary winding, three phases. We know according to BA standards, these are the common things. These are the common things. And here A2, B2, C2, A2, B2, C2, A1, B1, C1, A1, B1, C1. Right, now in generally dot notations are it same actually. We should take here only. Now take this is as usually, normally. Secondary is normally star. My secondary is normally star. But modify this connection. Up to now we connected A1 to the B2. But now connect this A2 to the B1, B2 to the C1 and C2 to the A1. This is also delta but small modified. Now this is delta and star connection diagrams. Let's see here, draw the arbitrary delta. Draw the arbitrary delta, but remember this, here in between A2 to B2 vector B is there, parameter B is there. From A2 to B2 B is there. From B2 to C2 C is there. From C2 to A2, from C2 to A2, A is there. Here from neutral to A2, from neutral to B2 and from neutral to C2, A, B, C. This is as usual normal thing. But here some difference is there. We have to follow the phase sequence. So first arbitrary delta is taken. Arbitrary delta A2 to B2 B2 to C2, C2 to A2. Now tell me, from A2 to B2, what is there? From A2 to B2, vector B. From B2 to C2, from B2 to C2, what is there? From B2 to C2, C. From C2 to A2, A. One C. A, B, C. Phase sequence followed. A, B, C. Phase sequence followed. No problem. Phase sequence followed. We should follow the phase sequence, and always A is the reference. It should be here only. A is the reference because it should be at 12 o'clock. That is the reference one. So this is the arbitrary delta corresponding to this one. Now actually these two are in reverse polarity, subtractive polarity, subtractive manner, because this is not changed, but this is changed. I changed this one, but this is not changed. So in subtractive polarity, how we can draw the vectors? 180 degrees, right? So let's see. Here, this is in its upward direction. From the neutral, it should be in downward direction. And see, this is in downward direction. From the neutral, it should be in upward direction. From the neutral, it should be in upward direction. This is B. And see, this is C. This is C. From the neutral, it should be opposite direction. This is C. Once check it follows the fundamental. What is that? Fundamental ABC. The phase sequence. See here, A, B, C. Of course, it follows the phase sequence. It follows the phase sequence. And here, A2, B2, C2. It is also follows the phase sequence. No problem at all. Now superimpose these two. Now superimpose on a clock. This is 12 o'clock, 6 o'clock, 12 o'clock, 6 o'clock, 7 o'clock, 5 o'clock, 11 o'clock, 1 o'clock, 11 o'clock, 1 o'clock. Now tell me, sir, where is my minute sign? Always my minute sign is at 12 o'clock only. Always my minute sign is at 12 o'clock only. This is the reference actually. Where is my hour sign? Where is my A? My A is in this direction. Not exactly in downwards. Not exactly in downwards. In this direction. Nothing but this is my small a. If it is exactly in down direction, it should be like this. But this is not exactly downwards, with some phase displacement, with some inclination like this. Nothing but what is the time? 7 o'clock. What is the time here? 7 o'clock. So how we can represent? Primary is the delta, secondary is the star, primary is the delta, secondary is the star, and the time is 7 o'clock. And the time is 7 o'clock. It represents that 180 plus 30 degrees. 180 plus 30 degrees. Nothing but 210 degrees. This is the third one. We got a 210 degrees. We got a 210 degrees. This is the third configuration. You should remember this configuration. They will ask you question in your GATE exam. This is the third configuration. Next and last, fourth one. Up to now, we got 3. One is the 0 plus 30 degrees. Other one is the 180 minus 30 degrees. And other one is the 180 plus 30 degrees. These 3 completed. Yes or no? These 3 completed. This is how many? This is 11 o'clock. And this is 5 o'clock. And this is 7 o'clock. These 3 completed. Let's check the last one. Let's check the last one. For last one, I am drawing here the winding of the primary and the winding of the secondary. The winding of the secondary. Of course, according to BIS standards, A, B, C, A, B, C, and A1, B1, C1, A2, B2, C2, A2, B2, C2, A1, B1, C1. Now this is modified one. We know how we modified. We know that A2 is connected to B1, B2 is connected to C1, A2 is connected to B1, B2 is connected to C1, C2 is connected to A1, and here also we should modify now. This is also modified one now. So these three are connected to a neutral. These three are connected to a neutral. Actually, my dots are here. But this is undotted location, and this is also undotted location. Undotted, undotted. Dotted, dotted, undotted, undotted. Nothing but this is also additive polarity. This is also additive polarity. This is not subtractive polarity. So here during the vector notation, the vectors are in parallel to each other because I changed both the windings. Here I changed only this winding. This is not changed. This is dotted and this is undotted. Undotted and dotted, that's why both are in 180 degrees displacement vectors. But here both the windings are changed, that's why this is additive polarity. Subtractive manner is not correct. This is additive manner. So now arbitrary delta, I said you arbitrary delta, how we can write. This is A2, this is B2, and this is C2. Let's check it between A2 to B2. Between A2 to B2, capital B is there. Between B2 to C2, between B2 to C2, C is there. Between C2 to A2, A is there. A is there. This is generally the arbitrary delta, and this is our reference vector, arbitrary delta. Now let's go for star, arbitrary star. Let's go for arbitrary star. Sir, how it was? Generally in phase. I said you that these are undotted, so in phase. During the vectors, this is A. From the neutral it should be A. This is A. A is for A1. And from the neutral, this is B. This is B. Same direction. This is in same direction and this is in same direction. B. This is B1. And this is C in the same direction. This is C and C1. C, check it. A, B, C. It is also follows the phase sequence. It is also follows the phase sequence, so no problem at all. Now let's superimpose superimpose it on a clock. Take a clock. This is 12 o'clock. This is 12 o'clock. And 11 o'clock, 1 o'clock, 6 o'clock, 5 o'clock, 7 o'clock. We know. And superimpose the primary, nothing but a minute's hand is here. Minute's hand is here. What about hours hand? My hours hand or A1 is in this direction. Nothing but this is in this direction. This is my small a. Let's check it. What is the angle? So now tell me, the primary is the delta and the secondary is the star and the time is 1 o'clock. Time is 1 o'clock. This is lagged by 30 degrees. This represents that minus 30 degrees or 30 degrees lagging or 30 degrees lagging. 30 degrees lagging. 1 o'clock nothing but minus 30 degrees or 30 degrees lagging. This is for delta star configuration. So the last one is 1 o'clock. 1 o'clock is 0 minus 30 degrees. 1 o'clock nothing but 0 minus 30 degrees. These are the four configuration of delta star. Four configurations of delta star by changing primary winding and by changing secondary winding we got a four configuration and four displacements. They will ask you question. This is also very important. This is very important. They will ask you questions in GATE exam and IES exam, in all competitive exams. Right? Did you understood all this? Right? Now what is the conclusion of delta star? The delta star conclusion. Let's see what is the conclusion here. Let's see. For delta star we have four configurations. In delta delta and star star we got only two. But in delta star one is the delta star 11 o'clock, other one is the delta star 5 o'clock, other one is the delta star 7 o'clock, other one is the delta star 1 o'clock. Delta star 11 o'clock nothing but 0 plus 30 degrees, nothing but plus 30 degrees or 30 degrees leading. And delta star 5 o'clock means 180 minus 30 degrees, nothing but 150 degrees. And delta star 7 o'clock means 180 plus 30 degrees, nothing but 210 degrees. Delta star 1 o'clock means 0 minus 30 degrees, nothing but minus 30 degrees, nothing but 30 degrees lagging. These are the four different configurations of delta star. They may ask you questions on this. Very important for competitive exams. Are you okay? Understood? So this is about delta star. The third one. First one is delta delta. And next one is star star. In these two we got only 0 degrees and 180 degrees, 0 degrees and 180 degrees. But in this delta star we got four configurations. Understood? Right? The features of delta star compare with star delta we can see later. Are you okay? Thank you.